So good morning, everyone. Welcome to today's seminar. Before I introduce our speaker, I would like to make a quick acknowledgement of country. We would like to acknowledge the Wurundjeri people of the Kulin Nations as the traditional owners of the land in which the university stands. We respectfully acknowledge elders past, present and future. Today I'd like to welcome Dr. Chris de Gruyter. Chris is a Vice-Chancellor's Research Fellow in the Centre for Urban Research. Chris's research is in the area of transport and land use planning, with a focus on understanding the transport impacts of new residential development. Prior to joining RMIT, Chris was a Research Fellow and Deputy Director in the Public Transport and Research Group at Monash Uni. He also worked in transport planning for 12 years, both with the Victorian Government and in consulting. Chris's wider research interests span the areas of travel, demand management, public transport and land use planning. Today, Chris is going to talk about his project, understanding the allocation and use of street space in activity centres. Welcome, Chris.
Thanks so much, Nigel, and thanks everyone for tuning in to this. I'll share the slides now and tell me in a minute if you can see it. No. Hang on.
Yeah, we can see that, Chris. It's great.
Yeah, great. Now, is that going full screen now?
It's a little, it's possibly a little small. Can you maybe try?
Okay, I'll have to do it again.
It's clear though, we can see.
Yeah, I see how it's coming up. I think settings keep changing, and I'll close it down again. And
I think it is full screen, Chris. It's just that you don't have the broader slides, so they look a bit smaller. So.
Yeah, I don't even know how to get this off now.
It's all good to me, Chris. I think
just
that's
keep it.
Yeah.
Keep it.
Yep.
Go with it then. That's great.
You sure? Okay.
Yep.
All right.
Yep, just go with it.
Okay. I've never done it this way. All right. So yeah, this research was done last year, and there's another person on the line, Sayed, who is from the School of Engineering. Do you just want to say hello, Sayed, if you're with us?
Hello, everyone. Hello. Well, thanks, Chris.
Thanks, Sayed. Yeah, Sayed did all the data collection for this research, and it was a huge amount of data collection. We had some research funds available last year and had to spend them quickly before the end of the year. And so that was part of the motivation for this, I must admit. But another motivation was that often when I went into, shopping strips in Melbourne, activity centres, I would see so many pedestrians and often so few cars, and think, so many pedestrians with so little space. Has anyone ever measured this? And we're also seeing a lot of these parklets emerge where car parking had been converted to outdoor dining. And I still wondered, is anyone measuring this to understand the use of the street space? So we thought we would measure the use of the street space in Melbourne in activity centres. And this research is going to be presented at a conference later in the year. So any feedback is really appreciated. This is the first time I've presented this research to anyone. So really, really appreciate any feedback you got. Actually, these slides aren't going to be, let me just check something. Yep, that's okay. So as many of us are aware, allocation of street space is certainly contested. And this is particularly the case in activity centres. Example there is Brunswick Street and Fitzroy. Activity centres in Melbourne often have a mixture of land uses. They've got a high concentration of people activity, but it's often where you get a lot of high traffic flows conflicting with destinations in their own right. So people using the area as a place, but then also it has this strong movement function as well. And often that conflicts with each other. And despite you know, all the research out there saying we need to allocate street space in a fair and equitable manner. This has rarely been measured, and this is particularly the case in Australia. So what we decided to do was measure street space allocation and its use in Melbourne's activity centres. And these activity centres were mostly shopping strips. Another one there is Church Street in Brighton. And we did survey some locations in the CBD too. And by doing this sort of survey, we can get a better understanding of locations where street space could be allocated more equitably to users. And this is particularly relevant during COVID. So when we did this research last year, we did the data collection last year in October through to December, and we thought, oh, you know, is this going to be relevant? But it actually is, or it's still relevant today, because we're still seeing restrictions, and I think it's relevant outside of that anyway, because measuring the use of the street space has always been something that's been missing, I think. So previous studies in this field, there's been some in Germany, Netherlands, Canada, and Melbourne CBD. And most of them have found, well, all of them have found that space for car users tends to be oversupplied. So what I mean by oversupplied is that the percentage of space given to cars tends to be greater than the percentage of people using cars. And each of the figures here shows that. Particularly the case for Melbourne CBD, where cars are given 58% of the space, but are only comprise 2% of all users in the CBD. Pedestrians, similar sort of story, except for the Melbourne CBD, where we've got 89% of all people in Melbourne CBD being pedestrians, but they're given only 26% of the space. That's a bit simplistic, but it does sort of show that there is this strong imbalance. Cyclists tend to, in the European cities at least, and not really sure in Australia from previous studies, but in the European cities at least, certainly an undersupply of space, that there's a greater percentage of people cycling than there is space given to them, and public transport also to some extent. So the only study done in Australia is that one in Melbourne CBD on this topic that I could find, and that used household travel survey data. So it did it for the whole of the CBD, and it didn't look at individual streets or anything like that. Just considered the whole Hoddle grid. And most of these studies, except one, they measure people flow, so the number of people going past over a time period. They don't measure concentration, so how many people are in an area at a given time. And so the ones measuring people flow don't account for differences in travel speeds between different transport modes. And none of the studies have explored, well, what's associated with use of the street space? What factors, what characteristics of the street, characteristics of the activity centres is associated with use of the street space by transport mode? And so this research sought to address those gaps using a case study of Melbourne's activity centres. We selected 36 major activity centres in Melbourne, and they're pretty much all the major activity centres defined by Plan Melbourne that are located within 10 kilometres of Melbourne CBD. At each activity centre, we've selected one or two sites for surveying, because we want to get an idea of, if you say Sydney Road, for instance, the street space changes along the road at different points. So we try to survey parts where you've got like a clearway or car parking changes or a bike lanes introduced, to get an understanding of how those things change as you go along the street. So we also sought to capture a range of different street elements in our surveys: clearways, no clearways, bike lanes, no bike lanes, etc. And also shared lanes, because a lot of streets in activity centres in Melbourne have trams operating in general traffic lanes. So trams share the lane with cars, trucks, motorbikes. So we try to get all of this captured in our surveys. Now, Sayed, who's on the line, stood on the side of a footpath counting at every one of these sites for an hour and a half, and he counted the number of people going past, and he classified them by the transport mode they were using. And he also, with a measuring wheel, which was accurate to the nearest centimetre, we got one from Japan, which was a highly accurate one. He went across the roadway and measured each part of the street. How much street width is given to each element of the street, like the footpath, the bike lane, car parking, etc. And he did that from October through to mid-December. And various forms of restrictions were in place with COVID at the time, particularly in October. It was sort of similar to what we've got now. But then later on in kind of November, December, it wasn't. The restrictions weren't as extreme. But then March and April this year, we got a whole group of students from a transport planning class in the Bachelor of Urban and Regional Planning. We got them to do, as part of an assignment, these same surveys. So we got them doing them at about 20 of the sites. So not all of them, because I had to do it in groups. We wanted them to do it in groups. And what we actually found was that the overall findings didn't actually change much. There were more people in public transport in March and April than there were late last year. But the overall conclusions that I'll present in this research didn't actually change much. So it does sort of show that these findings hold in periods of not as severe COVID restrictions, I guess, if that makes sense. Sorry if this part's a bit technical, but because we're counting people going past at crossing an imaginary line, if that makes sense, we naturally count more people going past in cars because cars move quicker than people walking, for instance. And people walking stop and stand still. And so we thought a better measure of use of the street space is this term called concentration, which is people per kilometre, number of people per kilometre. So if you were to look down the street, take a photo or a series of photos over the survey period, that would give you an estimate of concentration. We actually tried taking photos, but it was very hard because you've got to stand in the middle of the street when there's no cars in your way, and it gets a bit difficult. And it's also hard to see people on footpaths because car parking sort of blocks your view. So instead, we converted our data to concentration, and we did that using this formula: people flow divided by the speed for a given mode. And we got speeds for Melbourne. We didn't measure them, but we got them through previous studies specific to Melbourne, walking speeds, bike speeds, etc. The car, truck and motorbike one, so this is general traffic, we assumed that they travel at 75% of the posted speed limit. And in pretty much all of the activity centres we surveyed, the speed limit is 40 kilometres an hour. So 75% of it makes 30 kilometres per hour that we assumed as the average speed for cars, trucks and motorbikes. So it does sort of show how that compares to the other modes there. So what that does, when you look at concentration, it factors down the car, truck and motorbike flows because you divide it by 30, whereas for pedestrians, you're only dividing it by 4.3. And then we also put together all these characteristics of the activity centres. And we did this using a very manual method because we only had around 60 sites. We had these data that we had measured on footpath width, whether there's bicycle lane and all these different things. Activity centre characteristics, we just measured it using GIS and other methods. We use census data to get some of the population figures. And we did this for every site. And it was actually a good thing to do in a very manual way because we could check each value as we compiled it. And we really got a good understanding of these activity centres and their street characteristics as a result. Later on, once we collected our data, we did a correlation analysis to understand well, which of these factors is associated with use of the street space by mode? Okay, so now I'll present the results, which is the more interesting part. Oh, sorry, before I do that, to do our correlation analysis, we did a very simple thing. We just use Pearson correlation coefficients for our continuous variables. I'm sorry if this sounds a bit technical. And we used another thing called eta coefficients for characteristics that were categorical, because we were looking at categorical versus continuous variables. All right, so the results. Overall, on average, can I just confirm again, if someone's able to turn on their speaker, can you see the full slide, unlike what I can see?
We can see the full slide. It's a little small, but that's nothing to do with you. It's
Right.
just the way it's displaying.
Can you see the labels on the graph?
Yeah, so I can see there's a percentage axis down the bottom of 0, 10, 20, 30, 40,
You can read that, 60. Okay. Yeah.
And okay. the top one's trickiest, but it's shared general traffic tram bus lane with buses, truck, motorcycle, and cyclists all up the end. Okay,
good. All right. Just because it comes up differently on my screen, sorry for that. So these are the results averaged across all 57 sites. And what we find here, so the darker bars of this chart are the percentage of total people observed, and the lighter bars are the percentage of total space. Now these percentages total more to 100 because we excluded zero values. So where a street element wasn't present, for instance. So if it didn't have bike lanes, we didn't include it. So we're just averaging based on street elements that were present. And what we find here is that street space for footpaths or for pedestrians was undersupplied. So the percentage of total people observed using footpaths was much greater than the percentage of total space they had. And it's kind of the opposite for the other street elements. But this is an average, okay, across all sites. And what we found is that there's much variability as you go site by site. And I'll show you the variability over the following slides. So this is for footpaths, just footpaths. So the y-axis is a percentage of total people using footpaths. The x-axis is a percentage of street width given to footpaths across the whole street cross section. And if you're above this 45-degree line, it would indicate that your space is undersupplied. That is, the percentage of total people observed using footpaths is greater than the percentage of total street width. And I should say here that this terminology of undersupply, oversupply probably isn't the best. It's just what we've used here. But our approach was to adopt this. It's a principle referenced cited in the literature called egalitarianism. And that means where the allocation of street space is considered fair, where space is allocated to each mode according to its demand. So it'd be considered fair, for example, if the total amount of people was 50% and the total amount of street space was 50%, if they were equal. So we've used that principle. You could use other methods, but that's what we've used. If we go through each street element, space for car parking was mostly oversupplied. Again, but there's a few exceptions here where it's undersupplied. So this shows the variability across the sites. For cycling, so for bike lanes, it was oversupplied in all cases. All right, so it never got above the line, but it did get close to the line in some cases. And I should make a point here that these bike lanes are pretty crap. They're normally a painted white line on the road, and that's about it. And at best, they were a painted green bike lane. So there wasn't really any protection other than that. So if you did have a greater level of protection in your bike lanes, such as Copenhagen-style bike lanes, you might see these results changing. But we didn't survey any sites with those. We were looking specifically at major activity centres in Melbourne. General traffic lanes. So this is where you've just got cars, motorbikes and trucks, so no public transport operating in them. They're exclusive general traffic lanes. They were generally oversupplied, but there were some cases where it's pretty close to the line here. Exclusive tram lanes, there weren't many of these, where there were a couple on, we looked at a couple on Bridge Road in Richmond and then a couple in the CBD area, but there's a huge amount of variability there, as you can see. General traffic and tram lanes. So this is where general traffic shares the lane with trams. And yes, there's generally an oversupply, but these individual sites here are quite close to the line in most cases. So, but some that weren't, some that are a bit further away. It's a similar story for general traffic and bus lanes. So where buses share the lane with general traffic. There's quite a few on the line, but there is a bit of oversupply here. And mixed results for lanes that are shared with general traffic, trams and buses, because there were a few of those, but there's not many of them, as you can see, each point being a site, an individual site. All right, and this is putting everything together. I could have just put all these together in one in one graph and just shown you that, but it is a bit much to take in. That's why I presented them individually. But you can see the variability here, not only within each street element, but across street elements. So with the percentage of total people using each of the street elements. Okay, I've just got 3 more slides to go on the correlation analysis. So what we did, we put together for each of those street characteristics I mentioned earlier, we collected. We did a correlation analysis to see whether there'd be much association with the percentage of people observed walking, using bikes, cars, car parking, etc. And where you have a green arrow, it means that there was a statistically significant correlation and it was positive. And where it's a red arrow, it means that it was a negative correlation, but statistically significant. Where there isn't any arrows, there was no significance. And what I really liked about this is that the results were all very intuitive. It probably just is obvious, the results, but it was kind of nice to get this result that the wider your footpaths, the greater percentage of people observed walking, and the lower the percentage of people using cars. Where there were bike lanes, there was a greater percentage of people observed using bikes. And it goes on. We've got these movement and place classifications here. I won't go into the detail there, but they do also make sense. So that was good. That was also reassuring. Public transport frequency. The higher public transport frequency, the more people are using bus and tram services. Makes sense. A lower proportion of people are using car parking. I think these ones are more interesting though, the activity centre characteristics. Just point out a few results. I mean, cycling had a lot of correlations that, you know, it kind of makes sense. In areas of lower car ownership, we're getting, in areas of higher car ownership, we're getting lower percentage of people cycling. In areas where there's a higher resident age, we're getting lower people cycling. These sort of things made sense to me. And yeah, I won't speak to all the results. You can see them there, but it was a good little exercise. The thing that's missing here, though, is we just did correlations. We haven't done any regression analysis to control for the effect of other variables. So this is just simple 2-way comparisons. But it does give a bit of an indication, I think, for now. All right, last slide on what does it all mean? Well, I think from the results, we could see that space for pedestrians was generally, it does have the potential to be increased because it was significantly undersupplied in a lot of cases, although not all cases. And this could be potentially done through converting on-street parking, as is the case with parklets for outdoor dining that's happening at the moment, that we're seeing a lot of. And space for bike lanes was found to be significantly oversupplied. But if you were to remove them or eliminate, reduce the space or eliminate them, would that necessarily help with our contemporary transport objectives around increasing the uptake of cycling? Probably not. So I think we do need to exercise some caution with that. The other thing is that averages are probably not a good idea because there is so much variability across sites. So this highlights the need for very much a tailored site-specific approach to reallocating street space. And those characteristics we found that were associated with sustainable transport modes, we should be planning for those where possible. But I also think some sort of regression analysis is needed. But we only have 60 sites, so we don't really have a large sample to go on. But it would be worth it's an exercise worth doing, I think. And of course, we should be measuring this more often. I think if we're going to reallocate street space, we need to measure it to know if what we're doing is right. And of course, there's so many other considerations that come into play. There's political considerations, there's business considerations, traders, all this kind of thing, ethical considerations. This is only one consideration, this measurement that we've done. But I think it's part of it. It should be part of it. These are the authors, so Sayed, who I've mentioned, and also Bill Young, who from Monash Uni. Sorry, I forgot to mention him at the beginning, but Bill's an emeritus professor in traffic engineering. He helped out a lot with those, converting those figures to concentration. Thanks very much for listening. Sorry if I went a bit over time, Nigel. I hope that was useful.
Terrific. Thanks so much, Chris. That was excellent. Thanks for sharing that today. I'll just stop the recording and we'll move into some questions.
Mm-hmm.